So this isn't a regular organic compost because we're actually growing the microbes. We're growing different types of bacterias and fungi, amoebas, flagellates. We're actually creating the environment to create these different types of beneficial microorganisms that are required in order for the plants to uptake nutrition from their roots. Okay, well, a lot of farmers, I'm going to talk first about what the chemical way that farmers have been told about, which is basically to reduce pathogens and weeds. Pathogens as in different bugs and things that funguses, and decrease the weeds. But what has happened is these chemicals have destroyed the microbiology in the soil. So when we come in and bring back the microbiology, especially bacteria create these glues, which increases the oxygen content in the soil, which means it holds on to water. So there's less watering needs. There's also less cost because we would apply these composts based upon fungi-bacteria ratios of the plants you're growing. Therefore, they don't need to buy all these chemicals. They don't need to have the labor to come in and apply these chemicals. And we're just constantly improving the soil. And ultimately, the end result with a perfect balance of microbiology in the soil, our plants produce more, they're bigger, and they're more nutritious, far more nutritious than they were. And you find a lot of farmers now, because they've been many generations of using chemicals, and things are getting worse and worse and worse, and they're having to buy different types of chemicals now because last year's didn't work. Bananas is a perfect example with the pathogen Fusarium that is attacking them. Every year they have to bring in a new chemical to fight it, but every year the soil gets depleted a little bit more. And the life expectancy of bananas now, if people do not go back to the microbiology and learn about this, is about 5 years. Bananas will disappear, and this is what will happen with the plants over time, especially our staple crops, our corns, or sugar canes. And if you talk to any of the elders, they'll remember putting corn in the ground 100 years ago and having amazing plants. And now they're having to struggle with all these costs to get something that's a fraction of what it used to be. But we can go back with the microbiology to where we were. We can regenerate our soils and bring back those plants fully alive and fully nutritious. Traditionally, people have been making organic composts with using your ratios, green, woody, and nitrogen, and having certain turn times. I think in the US, a pile needs to reach a certain temperature. I think it's 130, don't quote me on that, and then turn 5 times minimum in order to be considered USDA organic. They're not looking under the microscope. So the microbiological complete composts, we are mixing certain ingredients, getting basic temperatures, and we're only actually turning 2 times because we don't want to disturb those microbes. We want the least disruption to their growth. So we need to reach certain temperatures for certain periods of time, and we immediately turn. Once we've gone through, which is actually 3, where everything has a turn in the center of the pile, but it's only 2 turns. When you first create the pile, you have a center, and then you turn twice. Everything has those temperatures that are held in the center will eliminate the pathogens, eliminate what we call the bad guys, and the good guys will thrive. The difference is using the microscope, actually looking at our composts as they're being created, and knowing that we are full of the good guys and there is no bad guys. You know, the bad guys are eliminated. With traditional organic compost, they haven't taken it that far, so you really don't know. You can create a compost, even a static pile that sits there for a while and just breaks down into this beautiful looking soil. But putting it on your gardens, you don't know what you're putting on. You don't know if there's root feeding nematodes in there, or actinobacteria. Now, actinobacteria could be good or bad depending on what you're growing. For example, actinobacteria is amazing for the brassicas, the cauliflowers, the kales, the broccolis, but it's not good for corn and other crops. So it's knowing, really, it's knowing with the microscope, the microbiology is knowing what's in there. And if there are pathogens, amending for that, which is really bringing in more oxygen, or perhaps we need to inoculate with another pile to get the good guys up, because you get more good guys, the bad guys immediately go away. Everywhere in the world is a little bit different because we have different ingredients that are available to us. Here, we've been working on different recipes. It's basically 40% woody, 40% green, or 45%, and then a nitrogen on the outside. But we have to test them. Diversity is super important because you're feeding different microbes. And the quality of the material is really important too. If you're going to be having manure from cows or horses that have had vaccinations or hormone shots, that's actually going to be counterproductive. It works against the microbe growth, because those things are intended to reduce microbe growth. And different, like the greens, so a baby green that has not gone to seed will have more nitrogen in it in its young form, whereas grasses that have already gone to seed could be more of a woody. But the secret is always diversity. So our ingredients, we're still playing around with them. We're still finding recipes. It's like cooking. It's just like cooking in a kitchen. We're putting as many ingredients as we can together to create a pile that meets the minimum requirements. And that is a bit of a learning curve. It's experimentation, because it's dependent upon also including the weather, the dryness, the humidity, but we do need to meet these minimum requirements with our ingredients, and we need to toss them really well, mix them really well, chop them really well. So basically the secret or the magic of this new science is we've now discovered that we don't need to adjust pH in the soils. We don't need to amend the soils with nutrients, minerals, etc., which we've always been doing. It's the microbes that do all that for us. The microbes and the plant roots. And even though most of us have been eaten from organic gardens for decades, we're not getting the nutrition because we've never really understood these microbes. And really the only way you can understand them and stay on top of them is by having a microscope, and I'll show you the lab after this. Mixing this pile beyond what you think is needed or required. These guys are good at that. Like, so they're like, no, we're done. It's completely fine. Nope, we got to do it again. To get these ingredients really blended up. The other secret here is soaking everything overnight over at least 24 hours. You can have the best ingredients. If you don't soak them like we're doing here, it doesn't work. The moisture contents. So they have to be soaked. So all of these buckets will be soaking overnight to 24 hours. Okay. Yeah, like overnight will work. Well, it depends upon your material. We have rice hulls that have come from the coast. And I am considering taking these out because I'm noticing in our complete piles, they're not breaking down. We've been told they're organic. I don't think they are. So the microbes are taking care of it, but it's taking a lot longer. They're taking care of any chemicals that are in here that are going, but it's taking longer than it should here. Again, we're really blessed here because we can have a mature pile in 10 weeks, like ready to be applied. So in the north, it's taking them 4 months, 5 months, sometimes 6 months. And I think that's because of our environment, our weather, the atmosphere, etc., and these ingredients. We have 10% nitrogen, which is, we have goats here. So these two piles are the bedding and the poop from the goats. So I've only considered it one of the goat poop and one of a brown because it's a mixture. And then we have horse and cow. So a bucket of each. That's our nitrogen, which is 10%. Then we're doing 40%, 45% green, 45% woody. Sugarcane is from here. This is from Canara. And again, we're pretty sure it's organic. We have the leaves. What else do we have here? A banana. Banana here.
Banana leaves.
Yeah, banana leaves we've chopped up. Now, the banana, the locals say you can't use it because of the sap, but we've been using it and it works really good. Dr. Elaine, I asked her and she said, no, go ahead. And that is just paper, broken up paper, broken down. Yeah, this is sugarcane, fresh. It's part of our green. So another secret here, and I think anywhere, is diversity. It's like trying to get as many materials in there as possible. Now, once we mix this pile, and we're going to put it in our cage over here, it needs to reach 130 in 24 hours. This is to kill any pathogen. Now, once it hits 130, we hold it for 3 days. If it hits 150, we only need to hold it for 2 days. And if it reaches 160, for 1 day. So once we've met one of those, we turn. Okay, and it's like an egg. It's a 3-layer egg. So you've got your complete area. If you can imagine an egg in the middle, the center, that's what's heating up. Okay, so that center is going to be put aside. Okay, so we have to take off the top, put it here. Take the center, put it as a new bottom. Take the bottom, put it in the center as an egg. So we're going to make a nest, build it up, and we rotate. Everything gets in the center for one time. And the same thing, 130 for 3 days, 150 for 2 days, 160 for 1 day. As soon as we hit that, we turn again. You only need to turn twice because it gives everything a chance to be in that center at those high temperatures.
How do you cut it up like this?
These guys with the machete.
The machete?
Yeah, yeah. I mean, if we had a wood chipper, we would use that. You can also use a weed whacker. Now, our goal with these piles, as they're growing, I keep testing them, and when they're mature, is to get different fungi-bacteria ratios. We want to see good guy fungi, and we want to see abundant bacteria and different ratios. We also want to see nematodes, amoebas, and flagellates, because they're the predator of the soil food web. So the plant roots tell the fungi and bacteria, I need copper, I need potassium, I need magnesium, I need nitrogen. And the bacteria and fungi will go through the soil looking for this nutrients, bring it back in exchange for a gift, which is amino acids and simple sugars. The way that the plant root talks to these microbes is through the pH. This is why it is important we do not adjust pH. Okay, because the plant root's in control of that. And it might be doing a signal at the top of the root system with an acid pH, and it might be doing another one at the bottom with an alkaline, depending upon what it needs. It's a signaling system. So when we come in and adjust pH, as we've always thought was the best thing to do, we are creating a problem for this plant root signaling. Okay, so when the bacteria and fungi bring the nutrients back to the soil roots, that's great, but it's not soluble. Those nutrients are still not soluble. So this is when the amoebas and the flagellates and the nematodes come in, because they eat the bacteria and fungi and poop out the nutrient in a soluble form. And that's the soil food web. So that's why we're not making compost for the plants. We're making compost for the bacteria and the germs. We're growing. It's like a ferment. It's like a sauerkraut or a fire cider. We're growing the microbes, the good microbes. The other thing is it needs to be aerobic. All good guys live and thrive in an aerobic environment. All pathogens, it's an anaerobic environment. So I'm really happy to see nobody's wearing masks, because we're part of the soil food web, and we definitely need oxygen in order to survive. I'm actually a naturopath, and I think even in the natural health world, we need to get away from being at war with germs. We need to focus on how can we live in harmony, which is basically raising the good guys. Whether it's the microbiome in our stomach or our gardens, it's raising the good guys. The bad guys will go away because they don't like it. It's not a good environment. So it's a whole paradigm shift with this science that really applies to us as human beings as well. Compost tea drinking is because I believe the garden of the human being, the microbiome, is the center of all health. I don't believe that science understands how important, we're just starting to understand, we're very young. But the microbiome is very much like the soil. And in our systems, I mean, anybody who doesn't live from the land or has refrigeration or is cleaning or cleaning all the produce to eliminate the chemicals or eliminate the bacterias and pathogens, we've depleted the microbiome. And we probably have between 600 and 800 colonies of bacteria in our gut. Whereas an indigenous culture who doesn't have refrigeration and they're eating right from the land will have over 200,000 different colonies. These guys control our immune system. There's a gut-brain axis. It controls our moods, our mineral balances, our hormone balances. And we don't understand the importance of this yet. We're just starting to. So I had this idea, because everybody needs a microbiome reset. If we drink compost tea and you get it into the gut, will it benefit the human being? Will it benefit our microbiome? Will it improve our health and re-inoculate with the good guys? Now, there hasn't been a study done on this. When I looked into it, there has not been, and I'm not a scientist, but I do have a microscope and I do have some health knowledge. So with some friends, we're doing a little self-study, doing live blood before and after stool and urine samples, and we're looking at drinking the tea and does it have an impact? Does it increase our energy levels? Does it help us sleep better? Are we digesting more foods? Are we feeling better? Is our moods elevated? And it's just a simple study in our local little environment here to see if this is perhaps a medicine. Now, I've created 2 different piles for this. They're both vegan, so they contain no animal products, no manures. I get to look under the microscope to see if there is any pathogens before we drink. So I can almost guarantee, I mean, if the piles are bad, we're not going to be drinking them. And then looking at people's, because the live blood tells you who you are now. And it doesn't lie, it represents who you are now in this moment. So will this drinking compost tea have an impact? I think it will, and this is just a fun little community experiment to see if it can actually be something that's beneficial. There were some scientists that I spoke to who do drink compost tea regularly, but they wouldn't talk about it publicly because there has been no scientific studies on this, and they didn't want to be seen as cuckoo, they were weird people. But they really helped me with creating these piles, knowing what ingredients to use, how to prepare the tea. And then the other thing is my interest in these composts are living. It's a living being. It's a living thing. And if we were to feed medicinal herbs, for example, nettle, if somebody has some joint issues or kidney issues, and nettle would be a good herb for them. If we were to feed that compost with the nettle plant, because it will eat it, all that bacteria and fungi will eat that nettle, are the medicinal benefits now in that compost? Because that bacteria have broken it down. Maybe different to the way that our bodies break it down, or if we're making an elixir or tonic, we can actually alchemize and break it down in another way. Will that big bacteria and fungi make that medicine more available? I don't know. Again, I'm not a scientist, but I have a suspicion it's possible. So I have a suspicion this could be a way of bringing medicines in effectively to help people. It's a supplement, so it helps short term, but long term it causes more damage. So it's like if I was to put, and this is why we've all had success as organic gardeners, we take our compost, especially with a lot of caca, and we throw it on our garden and we get these big, beautiful lettuces and broccolis and all these other things. But that's because we're infusing with a nutrient in a short-term period of time. It's not sustainable. In fact, it's probably doing more damage because those good guys are deteriorating. They're like, this is too much. And it's the same with supplements for the human being. We have to get back to the whole process rather than extracting and taking these things. I think Suzanne told me a story a while ago in one of her compost piles. They just decided they were struggling with some of their gardens, and they just decided, I'm going to put a bunch of seeds in this compost. They just made a compost, and they got these amazing produce, whatever they were growing. I don't remember. So she's like, great. So she did it again. Once that was harvested, put it, and nothing came back. And she's like, what's going on? And especially with nitrogen, and nitrogen is a salt. So it will give the plant this boost of energy, and it looks absolutely beautiful, but it has no nutrients in it. It's like a bodybuilder who's using all these supplements to get big muscles. It's not real. Okay, so it's going to give a good result initially, but long term it won't sustain itself unless you keep throwing that nitrogen in. But you're not fixing a problem, and you're not getting any nutrients. Well, I mean, nitrogen and nitric oxide is just one part of a big puzzle. Yeah. And it needs to work with the coppers and the irons and the magnesiums, and there needs to be a balance, and we don't understand that. And so getting back to the whole process, whether it be whole foods and elixirs and soups and complexes we make for the human garden or this for our garden, is the solution to our world health crisis. Okay, well, let's get started with this. Richard, Joanna, por favor. All the requirements, but it's just moved yesterday, so this is about 3 weeks old, and we'll let it sit here. It needs to stay, it's a little dry right now, but it needs to stay at about a 50% moisture level as it's maturing, because the good guys need that water. So the way we test is you take a handful, and if you can squeeze and 2 or 3 drops come out, it's a 50% moisture. This is probably 35%. It needs to be watered. And that's important. The water level is important for the good guys to grow. So
It should be at ambient.
to
when
come
it's
down
finished.
to ambient temperature. So I actually, well, mine has after the second turn, the third center has been, or the third section has been in the center. Sometimes it can get up to like 140 after that, and I've just been leaving it. You know, I've just been leaving it, and it slowly comes down. I haven't had to turn again, and so it's working. It's working. Now, if it got up to like 150 or 60, I probably would turn it because that heat, if it gets up to 170, you kill everything. And that heat will also create actinobacteria. And actinobacteria is both a good guy and a bad guy. You know, actinobacteria is amazing for the kales and the broccolis, but it's not so good for the other vegetables, and especially not good for trees. And Dr. Elaine actually instructs us too, but some of us are playing around with not and just having some patience as long as it doesn't get too high, and it's working for us. So Richard and Joanna will be picking. Really, we're going to make 2 piles and mix it back and forth and put it in here. So they're going to be taking from. We do need to drain off the water. Yeah, some people, if you want, we can start draining some of these buckets, just getting out as much water as we can, which is just tipping it.
No, I just read it.
Enough, and Richard's like, nope, we got to do it again. And he does it again. So, and I appreciate that. The really good is if I just hit the temperature requirements in the beginning, and it's really close. It's like, oh, is this going to be a failure? What I'll sometimes do is take grains or seeds, like a soybean or a chick or corn, and I'll soak them for 2 or 3 days to almost get to the sprouting, and I'll mix it in the center of that turn. But that can go the other direction. It can be too much heat as well. The other thing is urine. Putting urine into the pile, that will help.
Oh, well.
Yeah.
Lady? You use the urine pure?
Or you have to mix it with water. I mix it with water, and I mix it with about 1/3 to 1/5.
Okay.
Yeah.
You do fresh or fermented?
I've only used fresh. Well, Emma is taking a sample of, there's 2 piles over here. These are 2 small vegan piles that we created because we're about to do a compost tea drinking study. So I'm taking about 15 volunteers who are willing to do stool, urine sample, and then I do live blood with the microscope. We'll do the live blood. We're going to drink the compost tea, and then we're going to do the test after. There has not been a study yet. And when I first started looking into this, because I'm always looking into how do we reset our microbiome, you know, what things do we need, and of course, now I'm learning about the compost. I'm like, this seems like, how can we get this into here, right? Yeah, so, you know, but there's risks because it's compost. But then if we're killing, and I'm able to look under the microscope, if we're killing the pathogens, then it should be good. So, I mean, I did a lot of thinking about it. I really looked for studies. There's no scientific data on this. But I did go into our student forum and like, is anybody doing this? And 3 scientists came forth and said, I won't speak publicly. They private messaged me, but I've been doing it for a decade. And their anecdotal evidence, the one man had colon cancer and he cured it drinking compost tea. Oh. And then there was another one who had severe candida, racked in the body, include the feet, his feet were just athlete's foot galore, very painful for him, and he cured himself. So they took me under their wing and started giving me advice, how to create a human compost pile, how to prepare the pile for drinking, what to do with it. So I've created, these are 2 different piles. They're vegan, so there's no animal products in them. They met all the requirements and they look good under the microscope. We're gonna, Emma's just taking a sample. We can look at it under the microscope with you guys too. It meets the minimum requirements. But what the scientists are telling me is we need to let it dry down, not be at the 50% moisture, because we want everything to go into a dormant stage. Right? Because live microbes will not get through our hydrochloric acid in our stomach. So it needs to go to this dormant stage, so we're making sure the cysts and the good guys are getting through. And he says he has a cooler in his kitchen from the compost pile he created, and he feeds it to keep it alive, just like a pet, because they're living microbes, and he feeds it with the herbs that he needs for his body. I'm like, no brainer! How can we get these medicines? Because the microbes are making the medicines more available to the human body, right? So, although I'm not a scientist, and this isn't official, I do plan to use this study to prove that drinking compost tea is beneficial for the human microbiome. And then the second test I'll do is actually doing enemas. Then move it over here. So when we turn this So we dilute the compost in clean water and we shake it up. And then we take a sample of this. Now there's different apps that the school has created where we do counts on our slide. We put 1 drop on a slide. And it is very scientific, and we do counts on this slide of bacteria, fungi, nematodes, amoebas, flagellates, and bad guys. And we plug these numbers in, and give all the formulas are there to give us our fungi bacteria ratio. This tells you the health of your soils. I don't really want to go retail. And if anything, I want to train women how to do it, and then do it in our microbe tienda, right? And because I believe that whole foods are medicines, and we've lost the art. So I'm just going to do a quick scan here and see if, the fun things that we see inside. I can see a nematode. Now this is from our compost tea. So I am letting them dry out. I'm not expecting to see too many live microbes, but we can see cysts and eggs and maybe even amoebas. There we go. Okay, so here is an amoeba. This is one of the good guys. This is what we call a testate amoeba. There's another amoeba in the center there. These little guys here are the bacterias. So, these are all little bacterias going around. These are good guy bacterias because they're nice and round. Bad guy bacterias look like corkscrews, or they swim like a snake. Good guys, and the good guys like to get together too. So you can have 1, or you can have 2 or 3, and then or they could be rods, and they all connect. When you get a whole bunch of connected, it's called lactobacillus rather than a bacillus, which is what we use. It's really good for the human being. Used to ferment milks and sauerkrauts, etc. I see the bacteria in people's blood too when I do blood analysis. But we have to change our mindsets. You know, bacteria are actually, each one of us is only 5% human DNA. 95% bacterial DNA. 95% bacterial DNA. We have to stop being afraid of germs. We have to stop sterilizing and trying to kill them and being at war with them. Yeah, this is really amoeba-rich. Here's a spore right here. You can see. Focus in
amoeba spore?
No, this will be a fungal spore.
Okay.
There's some good guy. Here's some good guy. It's not a very good sample to show you, but there's some good guy. Let me find another one because we don't need to know species, or we don't need to name bacteria or fungi. There are characteristics that make it good or bad. And that's all we need to know in the soil science. Is this a good guy or is it a bad guy? This is an amoeba who's propagating, making babies inside. This is a pollen.
How do you recognize that?
Because I took the lab tech course. In the course you're in, Zia, they do teach you a lot, but they don't teach you enough. And it's practice. You have to just keep looking and practicing and understanding. But I do want to find a good guy fungi. And these are aggregates. These are soil aggregates. And the interesting thing is, if you make a tea from a compost, you've got all the bacteria create glues. So you can spray your whole property, and they say to do it before a rain because those bacteria will create more glues to bind to the leaves of the plant. It's very different to our concept of if we're going in with natural, cayenne pepper or neem oil or garlic oil to kill something. You don't do it before a rain because it all gets washed off. Well, guess where that goes? Right into the soil. Guess what it does? It kills all these good guys. So that's great to see if you can get through our stomachs and into our gut. Take the smallest bacteria closest to it. So there's one here, one here. I usually take the finger off my pointer because it's about the same size, and we count the diameter. So I'm going to count 1, 2, 3, 4, 5, 6, 7. So the diameter is 7. Anything over 2.5 is a good guy. Yeah? Anything under 2.5 are called oomycetes, and they're bad guys. So that would be a pathogenic fungi, such as, what's that called? The powdery mildew. Right? That would show up as all these little tiny strands under the microscope. So we know this is a good guy. And what we basically do is we do counts. We have a way of looking at the slide, dividing it up, and we count things and put them into an app. I think I have my app open. So data entry, main assessments. So we do readings. And we do readings, we put them into the app when we do our counts. And then this is from the school. It calculates everything for us after we've done all of our counts and gives us a report that tells us everything we have. Now we know we have minimum requirements for the BioComplete compost. Which I'm constantly looking at all the time. Okay, so 135 bacteria per gram. 135 measurements of fungi per gram. This is not. So we get these funnels. We get our compost. We put the compost in the funnel in a coffee filter. We fill it with water. It has a hose down below it. We tap the hose. We let it sit overnight, and then in the morning you open your hose, put a little bit of that water into a container, a drop on your slide, and your slide is just like, it just looks like worms. They're all over the place, and you got to count them, and that's how you extract. Now, good guys try to get out first, because they're trying to get to the oxygen. So in the beginning, you have all the bacterial feeding and the fungal feeding nematodes, and they're good guys. So you make this extract, and you have hundreds of thousands in like an ounce of water, and you can spray over your gardens. Yeah, but you do need a microscope to do this work. I mean, you can't actually understand what you're growing with your compost unless you have a microscope. And that's I'm training Emma, and I'm open to training some other people. The cool thing is Joanna and Richard's son Yandri, he's 12. So he came to the workshop we did a couple weeks ago, and he went home and he said, "Mom and Dad, I want to quit school. I want to go learn this."
Yeah.
So they pulled him from school, and the director of the school in Vilcabamba called a meeting. It's illegal for you to pull him. They put the fear of God into them. He has to stay for 3 more months and finish this level, and then he doesn't have to go back to school.
Oh, that's
He's like, I want to learn the microscope.
But you think for making compost, for learning how to make compost, you really need to have your own microscope, so you can constantly
You really
monitor.
know. I mean, you can go by temperature, right? If you've met the minimum requirements of the temperature, pretty good chance you have a BioComplete, but not always. I mean, it was really difficult to take these 3 piles and get the numbers that Dr. Lang wants, right? And then there's the extracts and the teas. I mean, extracting and having that in the teas in the water. And we have to come up with our own recipes with the teas of what to put in the extracts to make things grow in there. And that's really difficult. You know, everybody's starting from square one based upon their environment
Yeah.
and what's going on there. What I found worked the best, I have an alternative coffee. It's got chicory, dandelion root, a little bit of chaga, and fermented oats. I decided to use it, and my fungi just went boom. I'm like, okay, fungi likes alternative coffee, right?
Wow.
And we'll have to source things like it's not good on the plastic. What I'm doing there is not good because it's creating an anaerobic environment. So finding cloth to cover so it still can breathe. If you have a microscope and you're constantly checking, you can tell, okay, you know what, we're having a problem right now, and you can come in with an extractee from another good compost and re-inoculate.
Mm-hmm.
And keep that going. We do want to get more microscopes, and I do really wish to get more people trained in this. I mean, well, Emma, you want to speak to learning. I mean, is it a hard learning curve?
No, it's doable. Yeah, I do a good choice.
Yeah,
I'm not super, like, I'm not every day into it, but like the time that I have for it, I really enjoy it.
But if I take what I'm learning about the soil and apply it here, if we get the good guys going here, we actually will uptake nutrition at a much larger level too. And everything to me right now appears upside down. Everything we thought, I mean, for example, iron. Iron is being such an issue in the natural health world and the allopathetic. You know, it's been everybody's anemic and we're short in ions. And there are markers in the live blood here that show a shortage of iron. There's no friggin' way here in Vilcabamba we have a shortage of iron. We have adobe. We have red muds. Most gringos cook with cast iron. There's no way I should be seeing iron anemia. And it's not, people are short in iron, they're short in copper, bioavailable copper that works as a catalyst. But I think this all happens right here. Mm-hmm. And if it doesn't happen, and it gets absorbed into our body, we end up taking, most of the vitamins aren't even vitamins, they're hormones anyways, but our body goes into this storage mode, and it stores everything and it gets overloaded. So it's saying that, just a little piece of advice, a lot of research I've been doing, please stop taking especially D3. It's calcifying all of your bodies because it works with the iron and it works with the copper and it works with the retinol and it needs these special enzymes. It's not a vitamin, it is a hormone. D3 is a storage. There's 25 different types. It's a storage form. And if you are short on any of the above, magnesium, retinol, copper, magnesium, and everybody's short on magnesium because magnesium gets flushed in stress, and we're all under stress, right? Our body stores that vitamin D that you take in that supplement. We have iron overload. So the kidneys work really hard to try and get rid of that, and it's calcification.